Okay guys, hope everybody is staying safe out there. We're on 10.2 right now. This will be Monday. I believe it will be the 3rd of May that we are doing this today. And then what we're going to talk about today is arcs and chords. That's 10.2. Okay. First we're going to go through a couple definitions here, and again, make sure overall, some overall messaging here. Make sure again you're showing work. Make sure you're staying up to date on everything. You're doing all the assignments when they're, when I'm putting them out to you on the schedule. You'll get a schedule each week. I think that's probably the best way to do this. Okay. First off, we're talking about a central angle. We're talking about a central angle. That's going to be the angle that basically comes off the center of your circle right here. And in this case, angle P would be your central angle. Okay, that would be your central angle. And the next thing we're going to look at is an arc. Okay, and the first thing we'll look at with respect to arcs is your minor arc. Okay, your minor arc is going to be less than 180 degrees. So your minor arc here would be arc AB. And we draw that like this, AB with a little arc over it. That's how we're going to show arc. Okay. Your major arc here, so this is your minor arc here, AB. Your major arc here would be greater than 180 degrees, and that would be ACB. We incorporate the C because that's telling you that it's going the opposite way here. It's going to go this way, so it's greater than 180 degrees. Okay, so that's arc A, C, B. And again, put the arc above it. Okay, a semicircle, we've seen that before. That's just an arc that's 180 degrees. And again, if you had that, you would be looking at something like this. This would be your semicircle. Obviously, it just cuts right through the middle, and this would be your semicircle going right around here, 180 degrees. Okay. The measure, again, a couple things to note here. The measure of a minor arc is going to be equal to the central angle that intersects the arc. So, say if this angle right here was 80 degrees. Say if we said this angle was 80 degrees. This arc would also be equal to 80 degrees. So whatever your central angle is, that's what your arc is going to be, okay, degree-wise. Okay. The measure of a major arc is basically you're just taking that number away from 360. Okay. It's going to be equal to 360 minus measure of the associated arc. Okay, so the measure of the major arc, say if this was 80 degrees here, okay, we would have our 36, say 360, all right, and we would take away 80, and that would give us our major arc here. Okay, major arc here would have a measure of 280 degrees, right? So that's how we would find our major arc. Just take the minor arc away from 360. Okay. Okay. Moving forward, we're going to find the measure of each arc. I'm going to circle R right here. Okay. We look at MN right here, since our central angle is 80 degrees, the measure of arc MN is also going to be 80 degrees. So this is your arc right here, MN. This is your central angle. Your arc is always going to equal what your central angle is. Okay. Later on, we're going to get into inscribed angles, which will be a little bit different. Okay. So if this is 80 degrees, and we know that we're going to have this right here as 180 degrees. Okay, I'm actually going to I think I'm going to do this one next, do C next. So this is 80, okay, and they're asking you for arc PMN, okay? That's the full semicircle right here. Arc PMN, again, we're going to be on C here. Arc PMN is going to equal 180 degrees, okay? I just like doing that question next, and that was for C. So arc PMN is 180 degrees. Arc MPN, okay, MPN, we're going to go around this way. There's P in the middle tells you to go in this direction. You go around this way, and that's just going to be 360, okay? Minus the 80 is going to give you 280 degrees. So our MPN is going to be 280 degrees. Okay. Okay, so that's basically just going around the circle and finding the measure of each arc. We're going to look at example 2. We're going to do pretty much the same thing. This is a big part of what we're doing in this section. We're going to find the measure of each arc here. Okay. And they're going to ask you for the measure of arc GE. Okay. The measure of arc GE. And all that's going to be is just right here, GE. Probably should call that arc GHE, but they're just going to call it arc GE. Usually if they just go with the 2 letters, it's going to be the smaller arc. It probably should be arc GHE, but they're talking here about this arc right here, okay? And that's just going to be your 80 plus your 40. So that's going to be 120 degrees for that arc, GE, okay? GEF, okay, that would just be going all the way, I'll erase this, would take you all the way through E to F right here, okay? We're going to get 40 and 80 is 120, plus your 110, and that's going to give you a measure of 230 degrees, okay? And then to find arc GF, all you're going to do here is just take away, you know, if this whole part right here, going from here to here, is 230, they're asking you what GF is, we're just going to take 230 away from 360, okay? And that's going to give us a measurement of 130 degrees, okay? So that GF is going to be 130 degrees right here. Okay, that's the measure of that arc. Okay, the arc addition postulate, and I'm going to leave this visible right here because I think this diagram really helps you. And it basically, you know, we say how sometimes you have different postulates that are, it's kind of common sense. The measure of an arc formed by 2 adjacent arcs, an arc GE formed by 2 adjacent arcs, is the sum of the measures of the 2 arcs, which we just knew looking at that. You're just going to add these 2, or add this arc and this arc, and it's going to give you the one whole arc right there. Okay, so through doing those examples, we kind of worked ourselves into that postulate. Okay, congruent arcs are 2 arcs in the same circle, or congruent circles with the same measure. You know, anything that's congruent is going to have the same measure, and obviously, you know, congruent arcs are the same as everything else we talked about: congruent angles, congruent lines, congruent segments. Okay, let's work our way down here. And we're talking, and this is one thing we covered a little bit back a month or a couple months ago we're talking about a chord. A chord is going to go from one point on the line to another point on the line. So it's going to be a segment going from one point on the line to another point on the line. What this theorem says is that in the same circle or congruent circle, two minor arcs are congruent if and only if their chords are congruent. So what they're saying here is these two chords, BA and BC, they're congruent. So the two arcs, arc BC, is going to be congruent to arc BA. And the reason why is because the two chords, where the arcs have their endpoints, the two chords, okay, that are facing the arcs are going to be congruent. So the two arcs are congruent. Okay. The next theorem we're going to look at is that if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Okay, so basically they're saying here that if you have the diameter of a circle right here and it bisects a chord, then if it bisects, these two segments are going to be congruent. Okay, and also if these two segments are congruent, these two arcs are also going to be congruent to each other. Okay, so that's basically a theorem that's going to deal with your diameter here, bisecting a chord. Okay, basically bisect, we say it cuts in half. We've talked about bisecting angles, same basic philosophy here with the chords. Okay. Okay, this is kind of the reversal of the previous theorem. If you have one chord that's a bisector of another chord, okay, then the first chord is going to be the diameter. Okay, so if we have this bisecting through a chord, you know this is a diameter, okay, which always goes through the center. And just kind of a reversal of the previous theorem that we saw right there. And this is just one last example that we're going to have here based on what we know. If the two chords are congruent, we know that these two arcs are congruent. And if the two arcs are congruent, to solve this, obviously we know if two, whether we're talking about angles, segments, in this case arcs, are congruent. To solve this, we're just going to set these two equal to each other. Okay? Again, we always say looking at a picture is probably the best way to set up your equation. And then you would go through and solve this particular equation. X is going to equal 40. Okay, and they wanted you to find the measure of AD, so we know if x equals 40, 2 times x, or the measure of AD, is going to equal 2 times 40. So the measure of AD is going to equal 80 degrees. The measure of arc AD equals 80 degrees. Okay? So again, always look back. Make sure that you know they're finding not only x, but you also have to find a measure of AD. So we found x, but we also had to ultimately find a measure of AD right there. Okay. So that's it. Just the basics of arcs and chords, and we're going to get a little bit more into this in 10.3 and look at some other different characteristics. Make sure you're doing all your work. And again, if you've got any questions, email me, and we can get you squared away. And I can't stress enough, 2 things: show your work on everything, and make sure you're keeping up with everything, all your assignments every day.